In today's tutorial, we'll be discussing with you guys the quinoline and floroquinolones. And the points under discussion are number one, DNA replication in the bacteria, quinolines and fluoroquinolones, their difference. And in the third point, we'll be talking about the mechanism of action of the quinolines and fluoroquinolones. Let's start our discussion from the very first point, DNA replication. The very important point, the very important step. If you know about the DNA replication, then it will be very easy for you to understand the quinolines and fluoroquinolones mechanism of action. When a bacterium divides into two, that's called binary fission, and every cell needs to duplicate its cellular content. So here we'll be talking about the duplication of the DNA, and that is called as actually DNA replication. Now, how this replication takes place in the bacteria? If this replication is stopped, you can say then the growth of the bacteria is actually stopped. And what will happen? Then after a while, if it is not undergoing the process of growth, it might lead towards the death of that particular bacteria. So first, let us concentrate how this replication takes place. First of all, separation of the helical structure is supposed to happen. Now you have this particular DNA, circular DNA in the bacteria. Let's zoom this particular region here. Nitrogenous bases, purines, pyrimidines, they are actually then lining up and forming this helical structure. This helical structure is having the hydrogen bonds. Now what is going to happen to open this, separate this helical structure? Here we have an enzyme known as helicase, a DNA helicase, that will come and that will actually break these hydrogen bonds between the nitrogenous bases. Then these loops will be actually a kind free. Now you can say both the strands will be free for new DNA synthesis. Now what we need is in the next step, actually bacteria need, that is the DNA polymerase. That will come as the DNA polymerase observes the open and free strands, that will start bringing more new nitrogenous bases, and it will start, you can say, a kind of replication. So what next is going to happen is DNA polymerase will start the replication at both the ends, and it will start adding the nitrogenous bases. So like this, new DNA are actually supposed to be synthesized, two DNAs. So in the meanwhile, what will happen is this replication starts. This will create tension at the particular site. Now this tension will introduce supercoiling. Now this supercoil, if it is increasing, then it will be difficult for this DNA to replicate. So in order to eliminate this difficulty, or in order to reduce this difficulty, here next enzyme that is known as DNA Gyrase. Anyway, it's easy for you to pronounce or remember the enzyme name. DNA Gyrase, also known as topoisomerase 2. This enzyme will help this replication fork. This is actually known as replication fork. Okay, we have replication forks. Now at this particular region, at replication fork, this DNA gyrase topoisomerase 2 will come and will bind here, and it will facilitate the DNA replication. You can say it will start decreasing the supercoil. Now this supercoiling will not happen. You know what is coiling? This is called coiling, and this is called supercoiling. This is supercoiling. So during the replication, this condition is seen, supercoiling. So in order to avoid supercoiling, the DNA gyrase will come and will bind in this region, and like this the supercoiling will be reduced and the replication will be facilitated. So you can say that replication will take place in a very easy way. And what next is going to happen is topoisomerase 4. Now what is its job? Simple. The replication is continuous, okay? Now a point will come when we will be having two. Now this is one DNA circular, then we'll be having two circular DNA being held here. Now this is the point, the region where this enzyme topoisomerase 4 is supposed to come and to bind here. As this topoisomerase 4 comes and binds to this region, this will help in separating these two DNA. Now we will be having 1, 2 DNA. So we got two very important enzymes, and you are supposed to remember these two enzymes. Number 1, DNA gyrase, which is also known as topoisomerase 2, and number 2, topoisomerase 4. Topoisomerase 2 is supposed to facilitate the replication, and topoisomerase 4 is supposed to separate the synthesized DNA. Now remember these two enzymes, and let's move towards the mechanism of action of the quinolines and fluoroquinolones. Here we'll tell you people about the difference also. Regarding gram positive point of view, if we indicate the quinolines and fluoroquinolones, gram positive, the quinolones and the fluoroquinolones will inhibit the topoisomerase 4. Now, for a while, forget about the quinolones. Just concentrate the fluoroquinolones. So why? I will tell you the reason while I'm giving you the explanation of the gram negative. If we indicate the fluoroquinolones, they will inhibit the topoisomerase 4 in the gram positive. So when we are indicating the fluoroquinolones, they will inhibit topoisomerase 4. So if the topoisomerase 4 is inhibited, what will happen? Then remember the job of topoisomerase 4. It was supposed to open these two strands, to separate these two newly synthesized DNA, to have two separate DNA. So this separation will be blocked. Why? Because now fluoroquinolone has come and has inhibited the action of the topoisomerase 4. So when we give fluoroquinolone, F stands for fluoroquinolone, this will actually inhibit the topoisomerase 4. What will happen then? Then separation won't be observed. So like this, what will happen? If DNA is not replicating, if DNA is not available to produce its two copies, so then there is no development, there is no growth. So you inhibited it. And I told you, if the growth is inhibited, then somehow, according to this quinolones and fluoroquinolones, it is observed that they are actually acting like bactericidal. Now let's come towards the next point, that is the gram negative. If we are indicating the fluoroquinolones and quinolones, now I am including both the quinolones and fluoroquinolones. Why? Very simple. In the beginning, when the quinolones were discovered, they were supposed to inhibit just the gram negative topoisomerase 2. It means their action was observed merely on the gram negative bacteria. But with the advent of time, what happened? The synthetic modification took place in the quinolones. Means what we did was, we took the quinolones and we humans, scientists, we stands for human and scientist. So what they did, they actually introduced fluorine, and along with that, they introduced piperazine at 6th and 7th position of the quinolone. When you take the quinolone structure, when you count the numbers, at 6th position they added the fluorine, and along with that, at 7th position they added the piperazine. So after that, the structure of quinolones were modified. They were named as fluoroquinolones. In the beginning, when the quinolones were discovered, they were supposed to act just on the gram negative bacteria. Where was their site? What was their mechanism of action? Simple. Quinolones, when they were indicated against gram negative bacteria, they were supposed to inhibit the topoisomerase 2. Now, where is topoisomerase 2? Simple. This Gyrase enzyme, topoisomerase 2, which is supposed to facilitate replication, it was helping in decreasing the supercoil. So when the supercoil is decreased, then replication is going to be easy. So what these quinolones were doing, they were inhibiting the action of the DNA gyrase, topoisomerase 2. So when topoisomerase 2 is not doing its job, then it is just a kind creating difficulty for the replication. You can say replication is stopped by means of these quinolones. So quinolones are actually inhibiting the topoisomerase 2 enzyme. What? DNA gyrase, that is going to be inhibited. So when this is inhibited, then the mechanism is lost. It means DNA won't be replicated. What happened next? The scientists, they introduced at 6th and 7th position the fluorine and piperazine. After that, this spectrum was actually a kind broadened. So when the quinolones were modified, means when the fluoroquinolones were discovered, then those fluoroquinolones, they were able to have a broad range of action. Means they were able to act against gram negative. Along with that, they were acting against gram positive bacteria also. Now, what was the site of gram positive bacteria? In the gram positive bacteria of the fluoroquinolones, so fluoroquinolones were supposed to inhibit topoisomerase 4, and in the gram negative, they are supposed to inhibit topoisomerase 2. So in short, before we were having quinolones, then the quinolones were modified. Before quinolones, they were just effective against gram negative. When they were modified, the same quinolones, when they were modified, they were named as fluoroquinolones, and then these fluoroquinolones were actually able to inhibit both the gram negative and gram positive bacteria. Where gram negative, they were inhibited at topoisomerase 2, and gram positive, they were inhibiting the enzymes known as topoisomerase 4.